So what I've done here, we've concatenated a list of prophecies. Born in Bethlehem, king on a donkey, 30 pieces of silver, temple potter, and all that business. Wounds in the hands, no defense, though innocent. Died with the wicked, grave with the rich, and crucified. What's the probability of a particular person having fulfilled all 8 of them? Well, that's a dilemma, because now we're dealing with composite probabilities. And for the purpose of this discussion, we'll assume that these things are randomly distributed. Let's take a look at these 8 prophecies. I've made them in powers of 10, so multiplying them just becomes a question of adding up the zeros. See, 1,000 is 10 to the third, and 100 is 10 to the second, so 100,000 is 10 to the fifth. 2 plus 3, you with me? So all I need to do is add up the zeros. The probability of one person fitting all these things would be 1 chance in 10 to the 28th, but I need to work out the total people that live. So I take the 100 billion, I'm going to assume 100 billion population as a guess. So if I take the combined probabilities 10 to the 28th divided by 10 to the 11th, I now have still a very large number, a number by 10 to the 17th. I'll go to 48. Bear in mind, I got 300 to choose from, but I'm going to reach a little further. And I'm going to, again, assume there's no decrease in likelihoods. Actually, I can find prophecies there that are so rare they stand on their own in terms of this kind of analysis. But let's just assume that the rest of them, to make up 48, are no less likely than the first 8 we picked. Well, that's 10 to the 28th multiplied by itself 6 times, or 10 to the 168. And now I have to subtract my 10 to the 11th out of there, so that's 10 to the 157th. That's a pretty big number. How big is it? Well, the first problem I've got is silver dollars won't work. They're way too big. I need something small. I need the smallest thing you can imagine. What is the smallest thing you can imagine? An atom. Huh? How's that? It may surprise you to learn that there are estimates of the number of atoms in our galaxy. I want to make a ball of every atom in our galaxy. It turns out there's a commonly accepted estimate among scientists about 10 to the 66th atoms in our galaxy. Well, that means if I make a ball of every atom, if I'm going to consider them as my sample, I'm way short of what I need. I need 10 to the 157th. Okay, so I'll make such a ball for each atom in the universe. So now I got 10 to the 66th times 10 to the 66th. Well, that's 10 to the 132nd. I'm still far short of 10 to the 157th. Okay, I've got a ball for every atom in the universe consisting of as many atoms as there are in the universe. I'm going to imagine that crazy exercise happening every second since the universe began. Well, that's about 10 to the 17th seconds if you do the math. And now I'm still only 10 to the 149th. I've made a ball of atoms equal to all the atoms in the universe. I'm going to do that for each atom in the universe, and I'm going to do that whole silly thing every second for 16 billion years. Is that a big number? I am still short of my 157th. In fact, I'm short by over 100 million to 1. You say, okay, this is pretty silly. What's your point? Here's my point. I am more convinced that Jesus Christ was the Messiah of Israel. I'm more convinced of that than I am of any other fact in my command. I'm more convinced of his identity than I am my own. Now, I have no reason to doubt my identity. I've got a birth certificate. I know my parentage, etc. There's no little gimmick here. And yet, I also realize I could not attach this kind of certainty to any other fact I know of. And incidentally, we've only dealt with 48 of 300 beyond the realm of reasonable doubt.